Welcome to today's lecture. The subject is chemistry. Today we'll be looking at pH of mixtures. pH of mixtures. So let's see a problem. 200 cm cube of 0.05 molar HCl reacts with 300 cm cube of 0.02 molar sodium hydroxide. Calculate the pH of the resulting solution. You would need to listen very well. This topic is a little bit technical, so you would need to listen. Okay, it's a little bit technical. From the question, we can extract 200 cm cube of 0.05 molar HCl. We would need to convert the cm cube to dm cube. Don't forget, 1 dm cube is 1000 centimeter cube. So to convert cm cube to dm cube, you divide the cm cube by 1000. So if you divide 200 by 1000, you will get 0.2. The molar there is mole per dm cube. Don't forget, concentration is mole over volume. Concentration is mole over volume. The N there represents mole, V volume, C concentration. So if you cross multiply, your mole is concentration times volume. So the number of mole of the acid HCl will be the concentration given times the volume. That will give us 0.01 mole. We'll take the dissociation of HCl to be H plus Cl minus. The ratio of the acid to hydrogen ion concentration there is 1:1. So number of mole of HCl 0.01 mole as calculated from this point. The number of mole of hydrogen ion following the ratio is still 1, that will be 0.01 mole. We take up the base 300 cm cube of 0.2 molar NaOH. Don't forget, we convert the cm cube to dm cube by dividing the 300 by 1000. That will give us 0.3. The molar there is mole per dm cube. Number of mole of the base, which is sodium hydroxide, is concentration times volume. That will give us 0.006 mole. Writing the dissociation for sodium hydroxide, we have Na plus OH minus. So for number of mole of sodium hydroxide 0.006, since it is ratio 1:1, that of the OH minus will also be 0.006. Now consider the number of mole of the H plus 0.01 mole. Number of mole of the OH minus 0.006. So it means that the acid is more. So it means that we have to calculate the number of mole of the excess acid. That's excess H plus rather. Number of mole of the excess hydrogen ion in this solution. That will be 0.01 minus 0.006. That will give us 0.004 mole. We need to now convert the 0.004 mole to concentration. Don't forget, concentration is mole over volume, but now it will be the concentration of the excess H plus, which is number of mole of the excess H plus over the total volume of the acid and the base given. So we just put it there and we resolve the issue. That will give us 0.008. Don't forget, the acid is in excess, so we're going to quote the pH is negative logarithm of hydrogen ion concentration. The concentration of the acid, of course, of H plus there is 0.008. You convert this to standard form, and then 8 is 2 raised to the power 3 times 10 raised to the power minus 3. Applying the law of logarithm here, don't forget the formula is given to base 10, okay? So that will be log 2 raised to the power 3 base 10 plus multiplication in log is addition. So log 10 raised to the power minus 3 base 10. This 3 comes to multiply the expression. Minus 3 comes to multiply the expression. And of course, log 2 base 10 is 0.3010. I told you to commit this to memory. Log 10 base 10 is 1. 3 times 1. That's clear the bracket by multiplying through by minus. That will give us this. And eventually we get to 2.1. So the pH of the mixture is 2.1. We'll take question 2. 200 cm cube of 0.01 molar H2SO4 reacts with 300 cm cube of 0.02 molar KOH. Okay, let's change it to NaOH. Let's change it to NaOH. Okay, so we write the volume and the concentration of H2SO4 as given. Then we convert this cm cube to dm cube, and then we rewrite this molar means mole per dm cube. Then we get the number of mole of the acid, which is concentration times volume, and that will give us 0.01 times 0.2, and that will take us to 0.002. So we write the dissociation equation for the acid, which is H2SO4. Okay, that's H2SO4 giving us H plus SO4 2 minus. 2 atoms of hydrogen. We balance it up here to get 2. So the ratio of acid to hydrogen ion is 1 to 2. So number of mole of the H2SO4 is 0.02. That of the H plus, we have to multiply that value by 2 to get 0.004 since it is 2 here. Then we take the base. The base here is sodium hydroxide. So 300 of let's take it from the question. 300 cm cube of 0.02 molar NaOH. So we quote the value. The cm cube now is 0.3. Molar means 0.02 mole per gm cube. Sodium hydroxide. So number of mole of sodium hydroxide will be 0.02 mole per gm cube times the volume, and that will give us 0.06 mole. We write the dissociation equation for sodium hydroxide. That will give us NaOH, giving us Na plus OH minus. So NaOH will give us 0.06 mole. Okay, and that of the hydroxide, since it is ratio 1 to 1, that of the number of mole of hydroxyl ion will give us 0.006 mole. Now, if you consider the number of mole of the hydrogen ion, here is 0.004. Number of mole of the hydroxyl ion here is 0.006. Number of the hydrogen ion here is 0.004. So you see that the number of mole of the hydroxyl ion is greater. So number of mole of the excess hydroxyl ion will be 0.006 minus 0.004. That will give us 0.002. We'll now convert this mole now of the excess hydroxyl ion to concentration. Don't forget, concentration is mole over volume. So that will give us number of mole of the excess hydroxyl ion plus the total volume of the acid and the base. And eventually that will give us 0.004 mole per gm cube. Don't forget that the concentration we're talking about here is not of H plus but of OH minus. So POH is negative logarithm of hydroxyl ion concentration. And so we put the value there, convert it to standard form, applying the law of logarithm. Since it is multiplication, we use addition to separate the components. And then 4 is 2 raised to the power 2. Don't forget the formula is given to base 10. So we introduce the 10 to help us solve the problem. So 4 is 2 raised to the power 2. 10 raised to the power minus 3 base 10. And then we apply the other law of logarithm. The 2 comes to multiply. That's 2 log 2 base 10 minus 3 log 10 base 10. If minus 3 comes to multiply here, the plus sign changes to minus 3 log 10 base 10. Of course, log 2 base 10, I told you to commit this value to memory, 0.3010, while log 10 base 10 is 1. If you resolve this, you're going to get this. and then you clear the bracket with the minus, and eventually you get 2.398, approximately 2.4. So pH is plus POH is 14. So pH is 14 minus POH. So pH is 14 minus 2.4. That will give you 11.6. You will attempt the following question. Number 1, 50 cm cube of 0.1 mole per dm cube HCl is mixed with 40 cm cube of 0.10 mole per dm cube NaOH. Calculate the pH of the mixture. Number 2, 40 cm cube of 0.10 mole per dm cube HCl is mixed with 50 cm cube of 0.10 mole per dm cube NaOH. Calculate the pH of the mixture. You take your time, go through the calculations properly, and then attempt the question. I see you in the next lecture.